Hello and welcome. Today, we're unlocking the secrets behind the transformer architecture. Think about how we humans effortlessly understand long articles, conversations, and stories. We naturally grasp the context, even if words are far apart. For a long time, AI struggled with this, especially with lengthy text. Then, in 2017, a paper called Attention is All You Need introduced the transformer, and everything changed. This architecture is the backbone of many of today's most advanced AI models, like ChatGPT and Google Translate. Over the next few minutes, we'll break down exactly what makes transformers so powerful, focusing on how they process language and understand context in ways never before possible. Let's get started. Imagine reading a long book. To truly understand the plot, you need to remember characters and events from many chapters ago. Traditional AI models, like RNNs, processed information like reading a book one word at a time, trying to keep everything in a short-term memory. But just like us trying to recall a detail from page 10 when we're on page 200, these models struggled. This long-range dependency problem meant they couldn't effectively connect distant words or ideas. If a sentence was very long, the beginning might be forgotten by the time the AI reached the end. This limited their ability to understand the true meaning and nuances of complex text, hindering progress in areas like translation and summarization. The transformer architecture was designed to overcome this fundamental limitation. The transformer architecture, introduced in 2017, was a game changer. Instead of processing words one by one like older models, it looks at the entire input at once. The key innovation? A mechanism called attention, which allows the model to focus on the most relevant parts of the input for each word it's processing, no matter how far apart they are. Think of it like highlighting important phrases in a document as you read. The transformer is typically structured with an encoder that reads and understands the input text, and a decoder that generates the output, like a translation or a summary. Both the encoder and decoder are made up of several layers, and within each layer, this attention mechanism plays a starring role. This radical departure from sequential processing unlocked new levels of performance in AI language tasks. Self-attention is where the magic happens. For every single word in a sentence, the transformer calculates how relevant every other word is to it. It does this by creating three key components for each word: a query, a key, and a value. Think of it like searching a database. Your query asks a question, the keys are the labels for the information, and the values are the actual information. The model matches the query of one word with the keys of all other words to get attention scores. These scores tell us how much attention one word should pay to another. After normalizing these scores into probabilities, they are used to weigh the value vectors of all words. The final output for the word is a weighted sum of these value vectors. This means each word's representation is a blend of information from across the entire sentence, weighted by its relevance. This is how transformers understand context so effectively, even across long distances. To make self-attention even more powerful, transformers use multi-head attention. Instead of just one attention calculation, it performs several in parallel, using different sets of learned weights. Imagine reading a complex document. You might focus on grammar in one pass, the main arguments in another, and specific details in yet another. Multi-head attention does something similar. Each head can learn to focus on different types of relationships between words. Perhaps one head tracks grammatical connections, another tracks thematic links, and another captures specific word meanings. The results from all these heads are then combined, giving the model a much richer, multi-dimensional understanding of the text. This parallel analysis is key to the transformer's deep contextual awareness. Since transformers process words all at once, they don't naturally know the order of words. The cat chased the dog is very different from the dog chased the cat. To solve this, we add positional encodings to the word embeddings. Think of these as unique digital fingerprints for each word's position in the sentence. These encodings are mathematically generated so the model can learn patterns related to word order, like which word comes before another, or how far apart two words are. By adding these positional signals to the word information, the transformer can correctly interpret the sentence structure and meaning, ensuring that word order is properly understood. Let's put it all together with the classic encoder-decoder structure. The encoder reads your input sentence, using its layers of self-attention and feed-forward networks to build a rich understanding of each word in context. It then passes this understanding to the decoder. The decoder's job is to generate the output, like a translated sentence. It uses its own attention layers, including a special masked attention to only look at words it has already generated, and importantly, it uses cross-attention to look back at the encoder's output. This cross-attention allows the decoder to pick out the most relevant parts of the original input as it constructs the output word by word. This interaction between encoder and decoder is what makes powerful sequence-to-sequence tasks like translation so effective. So, what's the takeaway? The transformer architecture, with its self-attention mechanism, has fundamentally reshaped AI, especially in understanding language. It powers many of the AI tools we use daily, from sophisticated translation services to the chatbots we interact with. Its success has even inspired applications beyond text, in areas like image recognition. While incredibly powerful, research continues to refine transformers, making them faster, more efficient, and capable of handling even longer contexts. If you want to dive deeper into these concepts, understand the nuances, or explore more AI topics made simple, be sure to visit 8slides.com. You can also find more visual explanations and detailed breakdowns on our YouTube channel. Thanks for joining us.